So in this practice, verify that the wave function for a standing wave given by y equal 2a sine kx sine omega t is a solution of the wave equations. So wave equation is given by the second derivative of y with respect to t equal to v squared times the second derivative of y with respect to x. Maybe we could consider derivative. Round y, round t. It becomes 2a omega sine kx cosine omega t. Second derivative minus 2a omega squared sine kx sine omega t. This is second derivative. And the derivative with respect to x. In this case, 2ak cosine kx sine omega t. And the second derivative minus 2ak squared sine kx sine omega t. So by looking at each terms, you can only find minus 2a in both equations sine omega t. So from these equations, you can easily find to equate these two equations, k squared second derivative with respect to t equal, if you multiply omega squared by x squared. You can find these equations. From these equations, we could find the second derivative with respect to t omega squared over k squared round square y second derivative with respect to x, and b is expressed omega over k. This equation we can substitute here, then it becomes v squared second derivative with respect to x. So actually this is the wave equations. So we could confirm the standing wave given by the y equal 2a sine kx sine omega t is a solution of the wave equations. This is the answer to this